Welcome back. This is the second lesson recording for IM2, April 15th, 2021. Where we've left off, we were trying to figure out the area of this triangle, and we're going to use tangent of 22.5 to figure out the length of this leg of this right triangle on the left. And so that's going to be tangent of 22.5 is going to be equal to opposite, which is x, divided by 14.5, which is the bottom, okay, or the height of this triangle. So then you multiply both sides by 14.5 to find x. So x is going to be 14.5 multiplied by tangent of 22.5. Using the calculator, you get x to be approximately 6.01. Okay, so then now that we figured out what x is, oops, the x is here. What is the length of the side? The side length is going to be double that. That's going to be 12.02. Okay, so then area of this triangle is going to be half times base, which is 12.02 multiplied by height, which is 14.5. If I use the calculator, I get the area of this triangle to be 87.15. Then from here, I can figure out the area of the whole octagon is going to be, area of the octagon is going to be 8 times, because there are 8 congruent triangles, 87.15, and that works out to be 697.1 units square. So I've just figured out the area of this octagon. All right, so then let's try number 7. Again, this time we're just given the side length. Now, it wasn't the bottom, it wasn't the radii. We're just given the side length. Can we figure out what else do we need in order for us to be able to find the area of the triangle, which if I was to draw it, it would look like this. We need the bottom's length. Okay, so I'm going to call that x. And I can redraw this triangle here. And it is 5-sided. It's a pentagon. And I know that the bottom is going to be 7, so I know that this is going to be 3.5. That's all I've been taught. What else do we know? We know the central angle. That will be 5 central angles. That's going to make up 360 degrees. So if I divide 360 divided by 5, I get 72. So I know that this angle, central angle, is 72 degrees. So that means half of that is going to be 32 degrees. So I know that this angle right here is going to be 36 degrees. Half of 72 is 36. So now I have an angle measure on the left-hand triangle and what the opposite side length. So what is the trig function that uses the adjacent side and opposite side? That's tangent again. So tangent of 36 is going to be opposite, which is 3.5, divided by x. Now the x is a denominator. Okay, so what do we need to do in order to figure out what is the value of x? We multiply both sides by x. That cancels out. And then divide both sides by tangent of 36. So that leaves us with x is equal to 3.5 divided by tangent of 36 degrees. When I use the calculator, I get the x to be approximately 4.82. Now that we have this bottom side, we can figure out the area of the triangle is going to be the base times height times half. So it's going to be half times base is 7 times 4.82. and that leaves me with 16.86. So we found the area of one of the triangle to be 16.86. So the area of the pentagon is going to be 16.86 multiplied by 5, and that leaves us with 84.3 units square. Okay, so that's we can figure out. So even when we're just given the side length, if it's a regular polygon, we can figure out the rest of the measurements just by because we can figure out the central angle, and then we can figure out the area of the triangle, and then multiply that by the number of triangles and figure out the area. So now you're going to be taking notes as to the key steps. So finding area of a regular polygon, you need to first decide on the number of sides. This is the number of congruent triangles that you are going to be forming. Then decide what information are you given. Are you given the apophthegms, radius, or the side length? Okay, remember if it's a regular polygon, if you just know one of these, then you can figure out the rest. So then find the apothem and the side length so that you can figure out the area of the triangle. You can find the central angle if you need to, and use trig tool if needed. Then you can use them to find the triangle's area, and then multiply that by number of congruent triangles to find the regular polygon area. All right, so please copy this down because you're going to need that as you do them on your own. So now you're going to be working on the decimals activity, card number 1 to 6. So this is card number 1. Vida is studying the triangle formed by apothem and radii more closely. After some thinking, she claims that the blue segment is the same length as the red segment. The blue segment is same as the red segment. And the blue angle is same as the red angle. Do you agree with her claim? She's right. I can explain. She's right, but I'm not sure why she's pushing it. I don't think this is correct. Well, she is right. And how do we know that they are equal? It is by HL similar congruence, right? Because what we have is we're told that this is a regular polygon. So if it's a regular polygon, then this distance, the radii, and the radii is going to be the same. So the hypotenuse of these two triangles, the left triangle and the right triangles, are going to be the same. And we also have a shared side. That's a leg of a right triangle. So H hypotenuse and leg congruence satisfies the triangle congruence. That means the triangle on the left is congruent to triangle on the right. And then if they are congruent triangles, then we can conclude that the corresponding sides of congruent triangles are going to be congruent, and these are the congruent sides or corresponding sides. So that's why these two angles are equal in measure, and these two sides are equal in measure. All right, then let's apply what we just discussed. Sketch the triangle whose area we want to find. What is the measure of the central angle? Okay, so this time we're dealing with a pentagon with 7 yards as the side length. Okay, so this is exact problem that I went through during the previous lesson recording, so I'm not going to do that. I'm actually going to change the class problem. But you're going to work on this on your own. And if you need to go back and rewatch the lesson recording to figure out how to do this. Then finally, card number 6 asks you to find the area for this. It's an octagon, 8-sided. What is the measure of the central angle? Well, 360 degrees is going to be divided into 8 congruent triangles. So 360 divided by 8 is going to be 45 degrees. What about the apothem's length? Actually, I just changed the problem, so please disregard the previous problem. So card number 6 is this. This is not an octagon. This is a decagon. It's 10-sided. So sketch the triangle whose area we want to find. So the first thing is I am going to sketch the triangle. So if this is my center, I am going to find this will be my triangle. And what is the measure of the central angle? So this is 10-sided. So that's going to be 360 divided by 10. So that is going to be 36 degrees. So if I know that that is 36 degrees, I'm looking for the bottom and the central angle. I want to figure out what this angle is, and that is going to be half of 36, so it's going to be 18 degrees. And the bottom is the x that we're trying to find. Okay, so, or the height of the triangle. So we need to figure out the bottom's length. What do we know? We know that the total side length is 8, so that means this from here to there is going to be 4. So we have a triangle with an angle, opposite angle being 18 degrees, and the opposite side being 4. And we have x, the bottom. So we're going to use a trig function that deals with opposite and adjacent. This is the adjacent side, so that's going to be tangent of 18 degrees is going to be opposite, which is the 4 over x. So multiplying both sides by x and then dividing both sides by tangent of 18, that leaves me with x is equal to 4 divided by tangent of 18 degrees. When I use the calculator, I get 12.3. Now, what is the area of this triangle now? Now that I've figured out what the bottom is, I can figure out the area of the triangle. Area of the triangle is going to be the base, which is 8, or half times base, which is 8, multiplied by the bottom, which we just figured out to be 12.3. Okay, so then when I use the calculator, I get 49.2, approximately 49.2. So 49.2, and I submit. Now it's going to ask me what is the area of the octagon. I figured out the area of one triangle, and I know it's 10-sided, so there will be 10 times 49.2. So it's going to be 10 times 49.2, which is going to be about 492, and I am going to submit that. Great, we're going to shift gear a little bit, and now we're going to be talking about similar polygons. So if you are given this picture, and has the dimension of 4 inches by 6 inches, but that has now been blown up to 12 inches by 18 inches, what happened to the perimeter, okay, from the original? Can you compare the side length? How many times bigger is the perimeter? Okay, so the original was 4 by 6. What was the perimeter? In this case, 4 plus 6 is 10. This will be 4 and 6 again. So 10 plus 10 is 20 inches. What about this? 12 plus 18, that's going to be 30. 30 and 30 is going to be 60. So it went from 20 to 60. So the perimeter actually tripled. What about the side length? Side length went from 4 inches to 12 inches and 6 to 18. So the side length tripled and also the perimeters tripled. Okay, so notice that when the side length triples, the perimeter, since we're really measuring the length, is also going to triple.